So the logic gates are the combination of the switches or combination of logics. So if you are using a same button to switch on and off the device, you will find this a circle, so maybe you have seen this button. This is for, normally it is written for power. So actually, what is this symbol? This symbol is a combination of what? It is a combination of 0 and 1. When you press one time, it will on, the device will switch on. When you press the next time, the device will switch off. So if we can use the same button to switch on and off the device, you will find this symbol on it. Is it clear? The idea, this is the introduction of the logic gate. Basically, what the logic gates are giving an idea, these logic gates explain the idea about the logic of the circuit, whether a circuit will work or it will not work. And there are many logic gates. You have to learn 5 logic gates. You have to learn OR gate, the working of OR gate, AND gate, NOT gate, NAND gate, NOR gate. These are the gates you have to learn. So first we will start with OR gate. The symbol, the circuit symbol of OR gate, this is a circuit symbol. Where the two inputs are there. It has two inputs. And one output. So two inputs are there and one output for OR gate. And how it works, like what are the input? This one is the input, and what is going out is a output. Now how it works, the working of OR gate, it is easy to remember the working of OR gate. To find the result, to find the output of OR gate, add the inputs. So when we add the inputs, we will get the output. Example, if this is the OR gate, if this one is a OR gate and both inputs are 0, so 0 and 0, what will be the output? 0 plus 0. What is the answer for 0 plus 0? So that is equals to 0. It means that the output will be 0. If one of them is 1 and the other one is 0, what will be the output? 1 plus 0. 1 plus 0. That is equals to 1. And same thing, if we have 0 and 1, so output will be 1, and we have 1 and 1, so 1 plus 1 is 2, but we will not write 2, we'll write 1, because the logics which are possible, either it will be on or it will be off. So this is the OR gate. So basically what happened for OR gate, the circuit symbol for OR gate, and 2 inputs, 1 output. So what you have to learn the combinations, like if that both inputs are high, or if one of the input is high, the output will be high. If both inputs are low, the output will be low. We will discuss the applications. When I discuss the application of the logic gate, you will understand the concept about like how they can be used in the circuit. But right now, first what you have to learn, that's the first stage, that you should learn or memorize the output for different inputs of OR gate. Same way, if we are finding, so OR gate is by addition, and AND gate, if we have AND gate, it has the circuit symbol. So AND gate, the circuit symbol resemble with D. Letter D, AND is there, so same circuit symbol resembled with letter D. These two are the inputs, and one is the output. So it has two inputs and one output as well. To find the output, is the product of inputs. So AND gate output is a product of the input the chat, I think initially after when I join again, it was automatically disabled. So I enable chat again. If you have a question related to all this gate, you can mention your question. So AND gate output is a product of the input. So when we are finding the output for AND gate, like example, this is AND gate where two are the inputs. So if we have 0 and 0, what will be the output? 0 multiplied by 0. Product means multiplication. You will simply multiply them. So 0 multiplied by 0, that is 0. 1 and 0, 1 multiplied by 0, what will be the output? That will also be 0. Maybe my circuit symbol does not resemble with the standard circuit symbol of AND gate, but it is similar. 1 multiplied by 0, that is also 0, and 1 multiplied by 1, that is 1. So if you want the output of AND gate, you will multiply. If you want the output of OR gate, you will add them. So if we draw a logic table means a table which explain the results of input or relation between input and output. If I draw a logic table for OR gate and for AND gate, this is known as a logic table or also known as a truth table, which explain the relation between inputs and output. Input means where the electricity can come into the circuit. That's called input. And output means place where the electricity can go out from the circuit. Like example, in computer, you're using a keyboard to input the information, like enter the information. So that's why keyboard is an input device. But the screen on your screen, printer, these are output devices, so you can see the result which is generated by the computer. So same thing for logic gates also, where the electricity, charges or energy can pass through, that is the input. And where it can come out, that is known as output. So for OR gate, how we find the result? We get the result by addition. And for AND gate, how we get the result? By product or multiplication. So if I say the inputs are 0 and 0, 0 plus 0, what is the output for OR gate? So that will be 0. If I say 1 and 0, what will be the output? 1. Basically, when output is 1, it means the device will work. If output is 0, means the device will not work or circuit will not work. 1 and 0 is the meaning, shows which condition the circuit work and which condition circuit will not work. 1 and 0 and 1, that is 1, and 1 and 1, that is also 1. 1 plus 1 is 2, but because in a circuit logic there is no meaning of, we cannot explain the term 2. It can be 1 high or working, and it can be 0 means not working. So 1 plus 1 is 2, that's right. But in logic gates, the 1 plus 1 is also 1. That shows that circuit will work. If it is 0 and 0, 0 multiplied by 0, so it will be 0. 1, 0, what will be the output? The product multiply 0, 0, 1, 0 multiplied by 1, what's the answer? That is also 0. And 1 and 1, so 1 multiplied by 1, that is equals to 1. Now, where you're using this gate, like example AND gate, if you want to withdraw cash from the machine, ATM, so if you want to withdraw cash, inside the machine, it is having AND gate. First, what you do, what are the inputs here? The one input is a card, another input is a pin. Because if you want to withdraw a cash, you insert a card, but then what is the second step? It asks for the enter the pin. So the inputs here, there's an AND gate, and the inputs are the card. One input is a card, and another input is a pin, and then you have access to your account. So this one is input, this one is input, and access to your account is output, because once you have access to the account, you can withdraw cash. Without access to the account, you cannot withdraw cash. So example, you enter a card and machine read the card. So if machine read the card, if card is correct, so means that is 1. But you enter a wrong pin. If you enter a wrong pin, it means that is 0. So 1 0. Will you have access to your account? This is the AND gate inside the machine. So 1 multiplied by 0. So 1 multiplied by 0 is 0. So it will block. It will not allow you to access to your account. So the logic will be 0. Example, instead of inserting a card, machine readable card, instead of that, I insert, say, another card. Say you enter your driving license instead of the card given by the bank. So your card is wrong. If your card is wrong and the pin, even you enter a right pin, you enter a card which is completely wrong and you try to enter a pin, will it work? So it won't work. So you will not have access to your account. If you enter a right, like you enter a card which is machine readable and you enter a correct pin, then 1 and 1, both logics are 1. That time output will be 1 and you will have access to your account, so you can withdraw a cash. So AND gate is used in ATM. So it is using a logic that when both the inputs are correct or high, that case it will allow you to access. Otherwise, it will block your access. Is it clear? This example. So there are many applications for these, all the digital circuits based on these logic gates. Another type of gate is known as the AND NOT gate, or also known as inverter. What is NOT gate or inverter? Basically, the NOT gate, it has one input and one output. Other gates have two inputs and one output, but this gate is having only one input and one output. The circuit symbol for the NOT gate, this is a circuit symbol for the NOT gate. Look, what are the, like example, if I say a machine is working, what is opposite of machine is working? The opposite will be machine is not working. So invert, in terms of logic, what is the invert? If it is 0, what is the invert of 0? 1. Means why we call this as an inverter? Because it invert the logic. So if it is 0, it will make it 1. But if it is 1, it will make it 0. So it invert the logic, and that's why we call that as NOT gate or inverter. And where you're using this NOT gate, like example, in your car, you have a buckle for the seat belt, like this is a part of the seat belt, and there's a buckle, a metal. So what you will do, like example, this seat belt is not fastened or it is not connected, and this is passing through an inverter, and then there's a lamp on your dashboard. You will see the indicator. It can be a lamp or it can be a buzzer to indicate that the seat belt is not fastened. Example, if seat belt is not fastened, means it is not closed. So if it is not closed, what is the logic if it is not closed? 0 or 1? If it is open, so it is 0. So if seat belt is not fastened or buckle is not completely tightened, so it is 0. But when it passes through inverter, what inverter will make? 1. And when it will make 1, the indicator lamp will be on, or indicator will show you that, or there will be a seat belt sign will be there, or indicator which will blink or light up. But when you close this, when you connect the two straps, so when you connect the two straps, so the circuit is closed. So as the circuit is closed, it means now the logic is not 0, it is 1. So if it is 1, what inverter will make? Inverter will make it 0, and the indicator lamp or the buzzer will switch off. So basically, inverter, from name you can understand, if it is 0, it will make it 1. If it is 1, it will make it 0. So in your car, you have lot of digital electronic, because car is actually a mechanical system, because mechanical movement is there for the parts, as well as it contain electronics as well. So the electronic system is interface with the seat belt. So when you close the seat belt or fasten, basically when you close the strap, so it is a complete circuit. When it is a complete circuit, the input logic will be high. When input logic is high, the output, because it is passing through inverter, it will make it low. Is it clear, this example? So inverter basically inverts the input to output. What is the NOR gate? NOR gate is actually a combination of NOT and OR. When NOT gate combined with OR gate, what we call that as a NOR gate. So example, the circuit, and that's a circuit. This is a circuit symbol. This is a circuit symbol for OR. But if we want to make a NOR, we just make a circle at the output. So basically what happened, for OR gate, how we get the result? By addition. And for NOT gate, it invert. So it's a combination of addition and inversion. 0, 0. What is the output of OR gate? If there is a OR gate, 0 plus 0, what will be the answer for 0 plus 0? So 0 plus 0 is 0. But what happened? That is passes through inverter. So if it passes through inverter, what it will make? It will make it 1. So the output will become 1. Same thing. 1 and 0. What is the output of OR gate? For 1 and 0, the output of OR, that is 1. But when it passes through inverter, so when it passes through inverter, it will make it opposite, it will make it 0. Same thing, 1 and 1. What is the output of OR gate? The output of OR gate is 1, but that passes through inverter, so it will make it 0. Is it clear? The working of NOR gate, which is a combination of NOT and OR. And the last one is NAND gate. So the last one is NAND gate. NAND gate is a combination of NOT and AND gate. So basically for AND gate, what happened? It is by multiplication. The result of NAND gate is by multiplication, and NOT means inverter. It reverse. So if it is 0, 0, 0 multiplied by 0, what is the output of AND? What is the output of this part? 0 multiplied by 0. That is 0. And then it is passing through inverter. What it will make? So it will make 1. Same thing. 0 and 1 and passes through inverter. 0 multiplied by 1, that is 0, and that passes through inverter will make it 1. And if it is 1 and 1, the AND will make it 1, but passes through inverter, that will make 0. So if I summarize this, look, for OR, if how to get the result by addition. For AND, how to get the result by multiplication. For NOT, how to get the result by inversion. For NOR, how to get the result? First add and then invert. And for NAND, how to get the result? First multiply and then invert. Is it clear how we are getting a result of these logic gates? For OR, it is addition and multiplication. NOT is by inversion. NOR is by add and invert, and NAND is by multiplication and inversion. I'll share another link, but after a 5 minutes break, and complete, because the topic is not, the logic gate is complete, but when I explain application, you have better understanding. So after 5 minutes break, I will share another session.